Hi, and welcome to Mr. Fisher's Biology Podcasts. This podcast will look at pedigrees. So pedigrees show inheritance patterns in families, and a pedigree looks at a specific trait. And typically pedigrees deal with phenotypes. However, with a pedigree, you can usually determine the genotypes of the family members. Now, what would be some benefits to using a pedigree? Well, one of the big benefits that medical professionals use is to track the occurrence of diseases. So there are a couple examples of diseases right here. So take note of a couple of these. Some of these are examples, or some of these are genetic diseases that would be dominant, like Huntington's disease, and a lot of them are recessive. But with any disease, it's very important to know whether or not you have the possibility of transmitting that disease to your offspring, or whether or not you have the possibility of developing that disease later on. And a pedigree is a very useful tool to do that. So a little bit of symbols that we use in pedigrees. We give squares to represent males, circles represent females. If we don't know the sex of a person, maybe if the pedigree is going way back into a family line and there's not enough information to tell, we would use a diamond. Any individual that's shaded would be affected with the condition. Whether it's dominant or recessive, we shade the individuals that are affected. And typically, remember, it's dealing with diseases, so we're looking at individuals that have that disease. If they are married, we have what's called a marriage line, and that's a marriage line. And if it's a double line, it's a consanguineous marriage. And what that means is a marriage between family members. So a line coming off of the marriage line, that's an offspring line, and it denotes offspring that the family would have. In some cases, we will have twins. So if the twin line, which is typically this line here, comes directly off the offspring, they are non-identical. Identical twins have a separate little line that comes right off the twin line, and that would denote identical twins. So here's an example of a pedigree. Now this pedigree itself, you can see that the shaded ones would be affected individuals with whatever this would be. A couple other things, we number generations with Roman numerals. And the oldest offspring are typically on the left. And we go left to right. So let's look at some inheritance patterns. That's the next thing to look at. The first inheritance pattern we're going to look at is autosomal dominant. Now, these are not common because they are a dominant condition, and because they're dominant, the condition is very easy to pass on, and it can occur in multiple generations. So what I'm going to provide you with is some clues to identify different inheritance patterns. So first of all, an autosomal dominant disorder pattern, if it's autosomal, the disease is passed from father to son. Remember that with sex-linked traits, this would never happen. So in this situation here, this gives me a clue that it's an autosomal disease. The fact that it's occurring in multiple generations, this is a dominant. That never happens with recessive traits. And males and females are affected with the same probability. So in other words, another example that it's autosomal. Some examples of autosomal dominant disorders, polydactylism and Huntington's disease. Autosomal recessive. Again, males and females are equally likely to be affected. With autosomal recessive, the risk to unborn siblings of an infected individual is 1 in 4. So we see these less in the pedigrees. So in both of these cases, we see the condition less. And where these conditions can become problematic is if the parents are related. The rarer the trait, the more likely it is to develop the disease from consanguineous marriage. Examples would be cystic fibrosis and also a condition known as Tay-Sachs disease. So these are autosomal recessive. The last inheritance pattern is a sex-linked recessive condition. So with sex-linked recessive conditions, some of the clues are the disease is never passed from father to son. So this father here would never pass on this trait. Males are much more likely to be affected than females. Okay, so in this condition we see a male here and a male here affected. There's no females that are actually affected. All affected males are related through their mothers. So in this condition here, we notice that the mother, who's the offspring of the affected, her father, so the affected grandfather, she is related to that male. And the disease is typically passed from a grandfather, affected grandfather, through his carrier daughters to half of his grandsons. Now another thing that this pedigree is missing, but I will include, is that typically with the females, if they're a carrier, they will be half shaded. And that is a good indication that you have a sex-linked trait. So I will include the shaded carrier females because that's important to sort of delineate from, say, a recessive condition. Because they don't show up as often, it might be very hard to tell them apart. And so with all sex-linked recessive pedigrees, the females will be half shaded, and that means that they're carriers of the disease. Remember, a carrier won't show the disease in question, but it carries an allele that could possibly transmit the disease. So that's our podcast on pedigrees, and I hope that was helpful.